Good evening, everyone. Welcome to this tutorial session 5 on the course Mechanics of Solids, having course ID NOC-24 CE76 respectively. Today, basically, we'll be discussing on week 5 lectures. I will provide a brief overview of week 5 lectures, followed by the problems related to stress principles. So basically in this tutorial session, we will learn how to draw Mohr circle. Before that, we should know what is a stress, what are its form in the sense normal stress or shear stress, and their representation, followed by some numericals. In the numericals, we will see how we can solve the problems using graphical method as well as equations. Graphical method. And this graphical method is nothing but the Mohr circle method. So I hope this is till this point everyone is clear on what we will do today. So first of all, we should know what is stress. Second, what are the type of stresses we are going to deal with? Third, the principal stress and how to calculate the maximum normal stress and maximum shear stress using both the equations which are well established as well as the graphical method, which is nothing but the Mohr circle method. Till this point, is it clear? If everyone is clear, please let me know, or else I will move forward. Since no one is telling anything, so let us move forward to the question directly, because in this tutorial session, we don't have anything, means as of my knowledge is concerned, I don't think we have to go to any overview of the theory portion, because every theory portion has been taught in clear and descriptive manner in the lecture. And since you people don't have any questions regarding that or any doubts, then I assume you are well accustomed with the theory part from the lecture. So I am directly going to the question answer round. Is it okay? Okay. Let us start with this first question. Read the question. For the state of plane stress shown in figure 1, determine the principal stresses. So, in this square element, they are showing that sigma x is given as 50 MPa, sigma y is given as 10 MPa, and tau xy is 40 MPa. So let us write here what are given. Sigma x is 50 MPa and it is tensile. Sigma y is 10 MPa, which is compressive. So minus 10 MPa, minus represents compressive stress, and tau xy equal to 40 MPa. Now, they are asking to find out what will be the principal stresses. That means they want us to determine sigma 1 as well as sigma 3, which are nothing but maximum and minimum normal stresses respectively. Maximum and minimum normal stresses, or they are combinedly called as principal stress. So we know sigma 1 and 3 can be written as sigma x in terms of nodal stresses, sigma x plus sigma y by 2 plus or minus, that this plus represents maximum normal stress and minus represents minimum normal stress. So combinedly, this is the form it is written, or else let me write in the other way. Sigma x plus sigma y by 2 plus minus r, where r represents the radius, which is given as sigma x minus sigma y by 2 whole square plus tau xy whole square. And so let us substitute here. So what we will get, sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2, and this will be whole square plus tau xy whole square under. So from here, what can be written? Just we have to substitute the value. So we can write sigma 1 equal to sigma x plus sigma y upon 2, and this plus component sigma x minus sigma y upon 2 square plus tau xy whole square. Let me add one more slide here. Just wait for some time because my pen is actually not working. Okay. So sigma 1 is written as sigma x plus sigma y by 2. Let us write it here again once more. Plus sigma x minus sigma y upon 2 whole square plus tau xy whole square and under. So just we have to substitute the value sigma x 50 minus 10 and 40. So let us substitute directly with sign. Plus of minus 10 is minus 10 by 2 plus 50 minus of minus 10 will be plus 10. So I am erasing it and writing directly plus 10 by 2 whole square plus tau xy was 40 50 minus of minus 10 will be plus 10 square plus will be 40 square and that will be under root. So let us calculate 50 minus 10 is 40 by 2 is 20 plus 50 plus 10 60 by 2 whole square plus 40 whole square under. So you can write 20 plus 60 by 2 will be how much? 60 upon 2 whole square plus 40 whole square and that will be under. So this become 20 plus 30 square plus 40 square and under. So this become 20 plus how much it is becoming 30 square plus 40 square under root will be 50 square under root. So that will be 50 and this will be 70 MPa. So your sigma 1 value came out to be 70 MPa and your R value came out to be 50 MPa. So sigma 3 can be written as sigma x plus sigma y by 2 minus of sigma x minus sigma y by 2 whole square plus tau xy whole square under, and this value is nothing but R, and we got it to be 50 MPa. So you can directly substitute sigma x plus sigma y by 2 will be this value 20. So for writing, if I will write, now let me write 20 minus 50, and this will give you minus 30 MPa. So you are getting your major principal stress to be 70 MPa. This is major principal stress. And this is the minor principal stress, that is minus 30 MPa. So they have said us to calculate the principal stresses, and we know there will be two principal stresses. One will be the maximum normal stress, which will be called as major principal stress. Another one will be the minimum normal stress, which will be called as minor principal stress. And the values we are getting as major to be 70 and minus 30 respectively. So your option A is the correct option. So your sigma 1, that is the major principal stress, is 70 MPa, and sigma 3 came out to be minus 30 MPa. Minus 30 MPa represents what? Minus represents what?
Compression.
Yeah. So if the value is coming out to be positive, then that stress corresponds to tensile stress, or the nature of stress is tensile stress. If it comes out to be negative, then by closing your eyes, you should be knowing that negative represents compressive stress. So is this question clear?
In fact, I couldn't log in at the beginning, so I may have to go through before I
Anyway,
really talk about
you can
clarity.
just take couple of minutes and see the question. And I have already written all those formulas and solution. Please go through it within quick time. If you cannot understand any point anywhere, let me know now, or else we will proceed to the next question. From there, you start concentrating for this tutorial session.
All right, so let's go to the next question, and then I'll see how I can relate that.
Okay. Okay. Next
So the option
question.
is A.
Sorry?
I was asking whether the correct answer is A.
Yeah. Correct option is the first option. We are getting 70 and minus 30, na? So option A is the correct option. This one.
Okay.
Yeah.
Thank you.
Yeah. Just take note of this question, because in the subsequent questions also we have to refer this question, because those are parts of this major one. So take a note of this question.
Okay. Please continue.
Yeah. Now read this question. This is a continuation of our previous.
Continue.
This is the continuation of our previous problem or previous question. In a continuation only, we'll read this question. So let us read what they are asking. Determine the associated principal planes for problem 1. Means now in this question they asked what will be the quantitative values of the major and minor principal stress. Now they are asking if this is your lamina and where they are subjected to some type of stresses, that is sigma y, sigma x, sigma y and tau xy, and we have found out the principal stresses. So actually at which angle actually those principal stresses will be located. So we know directly we can apply the formula. We know tan 2 theta p is nothing but 2 tau xy upon sigma x minus sigma. This can be written in some different form also. Sigma x minus sigma y upon. So we know tau xy to be 40 MPa. Sigma x minus sigma y by 2 was 50 plus 10. So it is 30. 50 minus of minus 10 is 60 by 10 by 2 is 30. So it is 4 upon 3. So we are getting tan 2 theta p. So we can erase this part also. Let us directly take the value. 2 into 40
I cannot see
upon.
your screen.
You cannot see my
Okay, I
screen?
can see now.
Okay,
I can see now.
okay. So in this question, actually, they are asking what will be the value of the principal planes, means at which angle with respect to x and y axis the major principal and minor principal stresses planes will be located. So we can directly use this formula. We know tan 2 theta p equal to two times tau xy upon sigma x minus sigma y. So 2 into 40 upon 50 minus of minus 10. So 80 upon 60 equal to 4 upon or 8 upon 6, 4 upon 3. So 2 theta p equal to tan inverse 4 upon 3. So tan 2 theta p equal to, or let us directly write here, tan 2 theta p is 4 upon 3. So 2 theta p equal to tan inverse 4 by 3. Can you just provide me the value of tan inverse 4 by 3? Can you please tell me the value of tan inverse 4 by 3?
53.13.
Yeah, 53.1 degree. Degree. So from here, what can be written? Theta P came out to be 26.6 degree.
Yeah,
Correct?
correct.
Yeah. Now, and one more angle will be there for, because there are two major principal stresses. So two principal planes will come, which are supposed to make an angle of 90 degree between them. So other principal plane will be how much? It will be 26.6 degree plus 90 degree. So it will be 116 point something. Correct? Please let me know if you are getting or not. Till this point,
Okay.
is it okay?
Yes. Why are we adding 90?
Why?
Why are we adding 90 to the theta P?
Yeah. Since how many principal stresses are there?
3.
Two. There are two principal stresses, sigma 1 and sigma 3 or sigma 2 now.
Yes.
So
Yeah.
since there are two principal stresses and they will be acting on two different planes, so there will be two principal planes.
Yes.
So if you have two principal stresses, so there should be how many principal planes? Correct?
Yes. I can see what you have written.
Means is the screen visible or not?
The screen is visible, but your picture has covered what you have written.
Now, is it okay?
The screen is visible, but your picture has covered what you have written.
Okay. Let me erase this. If now you can see,
Yes.
if two principal stresses are there, then two principal planes will be there. Till this point, is it okay? Please tell me if this point is okay or not. Please tell me if this point is okay or not. If we have two principal stresses, then two principal planes will be there corresponding to each of the stress component. that is major and minor. Please tell me if this statement is okay with you or not. If not, then I will draw some figure to let you understand more. If it is okay, then I will proceed further.
It's okay. It's okay.
Yeah. Huh. If two principal stresses are there, there should be two principal planes. And we know since this is a lamina, and when it is getting rotated in some fashion such that it is now making an angle of 26.6 degree, then you are getting this plane as your first principal plane. And this will be your second principal plane where sigma 2 will be working. And this sigma 1 and sigma 2 is separated by what degree? 90 degree. That is the reason we are adding 90 to get the other theta b. I hope this is clear. If not, please let me know now. If yes, we will proceed further. I hope this concept is clear to all of you. So I am moving forward to the next. Okay, I hope this question is clear to all of you. So I am proceeding further without wasting time. see this third question. They are asking also determine the maximum shearing stress and the corresponding normal stress at which the maximum shearing stress is occurring. So this is just straightforward. You have to apply the formula. We know the maximum tau max will come as sigma 1 minus sigma 3 upon 2. So just substitute 70 minus of minus 30 upon 2. And this is nothing but the radius, that is 50 MPa. And the corresponding normal stress where this tau max is occurring will be how much? This will be sigma x plus sigma y by 2, and that is the center of the Mohr circle, which we will draw for some other question, not now. Okay, so it will be how much? 50, and this will be plus of minus 10 by 2. So it will be 40 by 2, and this will be 20 MPa. So 50 and 20 MPa respectively. So option B is the correct option. So please tell me if you understood the complete question or not. In the first question, they asked us to determine the principal stresses. In the second part, they asked, or second bit, they asked to determine the principal planes corresponding to the two principal stresses, what we have found earlier, that is sigma 1 and sigma 3. In the third question, they are asking to determine the maximum shearing stress and the corresponding normal stress for that given scenario only. So we are calculating tau max in which way? We know tau max will be the radius of the Mohr circle, which I will discuss later for some other question. Now, please keep it in mind that to determine tau max, we just need to find out the difference between the maximum and the minimum principal stresses divided by 2, which will provide us with 50 MPa for this condition, and the corresponding sigma n is nothing but the center of the Mohr circle, and that is given by the average of sigma x plus sigma y, and that is nothing but 50 plus of minus 10 upon 2. So we are getting 40 by 2, 20 MPa. So tau max is 50 MPa and the corresponding normal stress we are getting to be 20 MPa. I hope all the three questions till this point is clear. So let us move to some interesting question further. Just read this question and take your own time, solve for some time. And if you are getting anything, please let me know. Otherwise, after 2 minutes, I will start deriving the solution. And I will solve the whole question. So here, let me write the given things. Here, you can see sigma x is given to be minus 3 MPa. sigma y to be
This
minus 1.8 MPa and tau xy is 0 MPa because there is no shearing
will
stresses.
one question. Will you upload the YouTube videos today?
Sorry, I have uploaded already, right? Every video.
Can you hear me?
Every video before this session has already been uploaded in my portal. So tau xy is 0 MPa and they are writing theta is given as 15 degree. This will be minus 15 degree. So now what they are asking, determine the in-plane shearing stress parallel to the grain. So in-plane shearing stress parallel to the grain. So they are asking us to calculate tau xy at this theta when the angle of rotation is 15 degree clockwise or minus 15 degree as a absolute value. So tau xy can be written as minus of sigma x minus sigma y upon 2, and this will be minus of sigma x minus sigma y by 2
Hello, so
so this will become minus 3 minus of minus will be plus 1.8 by 2 and sine 2 theta will be sine minus 30 degree plus tau xy is 0 cos of minus 30 degree. So just substitute the value and tell me the answer, final answer, what you are getting. Please let me know the final answer, what you are getting. What is the final value?
zero point 0.3 positive.
0.3 MPa. Positive.
Yeah.
Positive means tensile. Now, the second question they are asking the normal stress perpendicular to the the grain. Normal stress perpendicular to the grain means this normal stress. Means now you have like this and you have just, you are cutting this and they are asking you to determine this value, sigma n. So sigma will be how
Hello,
much?
hello.
Yeah, yeah, yeah.
The answer should be negative.
This will be negative.
Yes, because
Okay,
this one, the sign minus sin theta is minus, and then in the bracket 2 is minus before there's minus in front here.
okay. This
Yes,
should be minus 0.3 MPa. Minus represents compressive stress. So now we are
compression. Yes.
calculating this normal stress. So the formula for normal stress we already know. So let us write that formula. Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2. And this will be cos 2 theta plus, and this will be sine 2 theta, and this will be tau x. So just we have to substitute the values. Let us do that. And I hope you are well accustomed with how these equations are coming. Assuming that only I am moving forward. If at any time, if you say you are not accustomed, we have to derive those equations.
Please, will you upload the video today?
Today, let me see. I cannot guarantee, but by tomorrow or day after tomorrow, it will be there.
Okay, because my internet and is on and off.
Anyhow, you just try to listen as much as possible now, because those answers I need. Otherwise, I have to calculate everything. So can you give me the value of sigma n, what you are getting? Just calculate those values, substitute it, and tell me the answer.
I cannot see your screen.
I think it is visible. Just refresh it if you are unable to see. Is it visible now?
Yes.
Yeah. Just calculate the value and let me know what value you are getting. Please tell me the values.
Negative 2.92.
Is it positive or negative?
Negative.
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 Okay, minus 2.92 then. So, from these two questions, what inference we are getting is that the question can be framed in different ways. In this question, they have provided us the principal stresses, which is 3 and 1.8 respectively, or 3 MPa and 1.8 MPa respectively. And in this question, since they have given us the principal stresses directly, they are asking us to calculate the normal stresses as well as the shear stresses at some different plane, which is 15 degree with respect to the principal stresses, and if it is rotated clockwise. So the overall agenda of this question is to let you know if some nodal stresses are given, you have to find out the principal stresses. The other way around also the question can be framed. And this is the other way around formation of the question. In what way? Because in these planes, you can see there is no shear stress. If there is no shear stress, these planes are directly called as principal planes. That means you know the principal stresses are 3 and 1.8 MPa respectively. So they have provided you the principal stresses, but they want you to calculate the stress component at certain plane, which is 15 degree when rotated, when the element is rotated 15 degree clockwise with respect to this orientation or this configuration. So I hope this is clear. So let us proceed to our next question. This is one of the interesting question you can find in this chapter, that is stress and principal stresses respectively. So please read the question carefully. My request will be try it yourself. Read the question carefully. Try it yourself. If you can't, I will solve at the last. But before that, I want all of you to try this question. Take time and try this question. Are you people able to understand the question? If it is understandable, please do it. If at any point anyone is facing any issue, please let me know now before I start the solution. So there was a network disruption from my side. Sorry for that. So let us read this question now. In this question, they are asking two wooden members of 80 into 120 uniform rectangular cross sections are joined by simple glued scarf splice shown in figure 3. Knowing that this beta angle is 22° and that the maximum allowable stresses in the joints are 400 and 600 kPa respectively, determine the largest centric load P that can be applied. So here I am drawing this part, taking it out and drawing this part. Just see. This is P. Okay. Now here one is normal and one is C. And this area is 80 into 120 square. So, and this angle has been given to be 22°. This angle is given as 22°, and this is 80 into 120 square. And let this be A. Now, what will be the area of this? If I write this to be A prime, this will be how much? A by sine beta or sine 22°. So what you can write 80 into 120 by sine 22°. So please calculate the value. So the value will be 25626.8 square. And this value was 9600. So now this N is the normal force that can be sigma allowable into area A prime, because this is the area where this normal force is acting. So sigma allowable is given as 400 kPa. 400 kPa means 400 into 10 to the power 3 Newton per meter square. And we have to make it to mm square. So 1 meter equal to 1 meter equal to 1000 mm. So 10 to the power 9 mm square. So you can write this to be, so overall what we can write is 40 into 10 power 3, that becomes Newton per meter square, and this becomes Newton per mm square into 25626.8 mm square. So how much we are getting? 40 into 10 power 3 into 25626.88 upon 10 power 9. So we are getting 1.025 Newton. Sorry, this is 400 actually. So let me write one more time clearly, because we have done some silly mistakes. You can write 400 into 10 power 3 into 10 power minus 9 Newton per mm. 40 into 10 power 3 upon 10 power 6 into 25626.8. So 40 into 10 power 3 into 10 power 6 into 25626. So we are getting 1025 again. Sorry. We are doing too much of mistakes actually today. This is 400 kPa. So 10 to the power 3 becomes Newton per mm square into 25626.8. Now you do 400 into 10 power 3 upon 10 power 6 into 25626.8. So we are getting 10250.72 Newton. Similarly, S will be sigma or tau allowable. S will be tau into A prime. So tau becomes 600 into 10 power 3 upon 10 power 6 Newton per mm square into 25626.8. And this is mm square. So S can be written as tau into A prime. Tau will become 600 into 10 power 3 upon 10 power 6 Newton per mm square into 25626.8. mm square. So whatever you will get will be in terms of 600 into 10 power 3 upon 10 power 6 Newton per mm square into 25626. So how much we are getting? 600 into 10 power 3 upon 10 power 6 into 25626. So we are getting 15,375.6 Newton. Till this point, everything is clear. Now, what they are asking is what will be the largest load P that can be applied on this given material. So just we have to take the component, divide it and write all those summation of forces along. Let this be x prime direction and let this be y prime direction equal to 0. So if you just divide this here, so this will become 22 degrees. So this will be P cos 22 degree and this will be P sin 22. So if you do summation of fx equal to 0, what you will get? X prime equal to 0, what you will get? This will be S minus P cos 22 degree equal to 0. And we have already got S to be 15,375.6 upon cos 22 degree will become P. So let us calculate. This will be 16,583 or 16.583 kilonewton. Similarly, if you do summation of Fy equal to 0, you will get n or minus n plus P sin 22 degree equal to 0. So from here, another P you will get as 10 to 50 by sin 22. So from here, we are getting 27,000 27,000 27.36 kilonewton. So overally, you can see 1P you are getting 27.36 kilonewton. Let this be P1 and this be P2. And P2 you are getting 16.583 kilonewton. So determine the largest centric load P that can be applied. So if you read this, then you can directly say if we apply 27.36 kilonewton, then obviously it is failing in shear. And if we apply 16.6 kilonewton, then In neither case, nor in normal, neither in shear, it is failing. So that means P load will be equal to minimum of both. That is minimum of P's, or PL will be equal to 16.60 and 27.36 and mean. So it will be 16.60 kilo. The answer will be 16.60 kilonewton. Will be your answer. I hope this question is clear. So let us move to our next question. Okay. Read the question. Try to solve. If not, I will solve for you. If there is any issue, please let me know and read the question carefully. The question is telling for the state of plane stress. So a lamina is given and the stress components, that is sigma x, sigma y and tau xy is given. They are asking if the lamina is rotated anti-clockwise or counterclockwise by 30° anti-clockwise, then what will be the stress generated at that orientation? That means you have to calculate sigma x prime, sigma y prime, and tau xy prime when this lamina or this element is rotated 30° counter. So for such type of question, it is always better to draw it or to solve it using more circle graphical method, or graphically, that is more circle method. So try to draw the more circle for this condition and try to answer the questions. Means you have to find that sigma x, sigma y and tau xy when this element is rotated 30° counterclockwise or anti-clockwise. When this element is rotated 30° anti-clockwise, then what will be the stress components? So first and the foremost thing in such question is to draw the Mohr circle. Please draw the Mohr circle and let me know if you are able to draw it or not. Or is there any issue you are facing? Okay. Let us draw a more circle. First, let us write the given terms. This is sigma x, this is sigma y, and this is tau x. So, given sigma x is 100 MPa, sigma y is 60 MPa, and tau xy is minus 48. Correct? Now, we can find sigma 1, sigma 3, and the location of principal points. Now, let us calculate first tan 2 theta. That will be equal to 2 tau xy upon sigma x minus sigma y. And that will be equal to minus 2 into 48 minus 2 into 48 by 100 minus 60. So we can write minus 96 upon 40. So minus 96 upon 40. So theta p will be 2 theta p will be tan inverse minus 96 upon 40. So that is tan inverse minus 96 by 40. So it is coming out to be minus 67.380. So theta p will be equal to minus 33.6. Correct? Now let us draw a more circle. This is tau, this is sigma. And what will be the center of this circle? This will be nothing but sigma x plus sigma y by 2. That is 80. This is 80. Now, you have already got wait. You have already got these planes. This is 100 comma 48. 100 comma 48. And this is 60 comma 48. This x coordinate is 100. This x coordinate is 60. This is 60. Received. Now we have also got the radius as such we haven't received, but now this angle we already know that is 67.38. Let us draw in some bigger manner because everything otherwise will get congested. Okay. This is tau. This is tau. This is sigma. This is our stress. The center is at 80. And we have already have these 2 points. This is 60. This is 100. And this angle is 67.38 degree. And this is 100 comma minus 48. And this is 60 comma minus 48. And this is 67.38 degree clockwise. And this will be tau max. We don't know as of now. And they are asking that when this element is rotated by 30 degree. So if this element is rotated by 30 degree, then in the Mohr circle, it will be twice that element, means this at this plane they are asking us to calculate which is from this point it will become 2 into 30 degree, that is 60 degree. So we want this, what will be the coordinate of this and this. If we can find the coordinate, sigma tau coordinate of this point, let this be A, and this point, let this be B, our job is done. So now, see, this is 67.38 degree and this is 60 degree. So what will be this angle? Let this angle be phi. Phi will be 180 degree minus 60 degree minus 67.38 degree. 180 degree minus I will be 180 degree minus 67.3 degree minus 60 degree. And we are getting 180 minus 67.3 minus 60. 380. So it is coming out to be 52.60. And this angle is 52.60. Now, what else we can write? Just see the diagram and tell me if anything else can be written or not. Just focus on the diagram and please tell me. I am also stuck. Let us see if we can write the equations or not. So now we can write the radius as 100 minus 80 whole square plus 48 whole square under root 100 minus 80 whole square plus 48 whole square under root. So from here we are getting this to be 50. So this length we have got to be 52 and this will also be 52. So if we do 52 cos phi, won't we get the normal stress component at this point? So let us do sigma at A will be 52 cos phi. So can we write that won't be sigma A? Can we write sigma A to be 80 minus 52 cos phi? So we can write 80 minus 52 cos 52.6. So we are getting this to be 48.344 MPa. Why I have written C? This is origin. From origin to center is 80. But we need from origin to this point what will be the value. So we can write from these two origin is 80 minus 52 cos phi. If you will do, it will reduce this portion. So we are getting the normal stress of point A. So and that value is 48.344. Now how to calculate tau A? Tau A is nothing but 52 sin phi. 52 sin, you are getting 41 MPa. 41.3 MPa. So sigma and A and tau A is known. Now you have to calculate at this point. So sigma B will be nothing but 80 plus 52 cos phi, because this will be a straight line, and if this is 52 degree, then obviously this portion will also frame 52 degree. So 80 plus 52 cos, so this is coming out to be 112.72 MPa, and tau B will be nothing but the same thing, 41.3 MPa. So the overall thing what we have got is that we are getting two normal stresses whose value are 48.344 MPa and 112.72 MPa respectively, and tau B means if we draw that lamina, then it is like this. This we are getting to be 112 point something MPa, 112.8 MPa or 112 MPa, let it be. So this is 112 MPa. Same for this side also. And here this is 48.3 MPa. And all those shear stresses are positive. So we can show it here as 41.3 MPa. 41.3 MPa. So this is the overall stress state when this element is rotated by 30 degree in the original space or physical space. So please tell me if this question is clear to everyone or not. If this is clear, please try this. Here I am directly giving you the hint. This is your x and this is your x prime. And similarly, this is your x and this is your x prime. This is your x, this is your x prime. So for first, if we are writing this 1 and this as 2, for first case, we have sigma x prime to be 200 MPa, sigma y prime to be 350 MPa, and both are minus because both are compressive, and tau x prime y prime equal to 0. And for this case, and theta equal to minus 30 degree. And for this case, sigma x prime is 0, sigma y prime is 0, and tau x prime y prime is how much? 58 MPa. And what is the angle theta? 25 degree. Just we have to use those three equations while the derivation has been done. That is, sigma x for 1 will be equal to sigma x prime plus sigma y prime by 2 plus sigma x prime minus sigma y prime by 2 cos 2 theta and plus tau x prime y prime sin 2. So if you just substitute minus 200 minus 350 by 2 plus minus 200 minus of minus 350 means plus 350 by 2 cos minus of 60 degree plus or minus 2 into 30 later, let us write. Cos minus 2 into 30 degree plus tau xy is 0 into sine of something. So from here, if we calculate, we are getting minus 237 MPa. Similarly, sigma y for 1 will be sigma x prime plus sigma y prime by 2 minus sigma x prime minus sigma y prime by 2 cos 2 theta minus tau x prime y prime sin 2 theta. So if we just substitute minus 200 minus 350 by 2 minus of minus 200 plus 350 by 2 cos of minus 60 minus, and this will be 0 into sine of minus 2 into 30 degree. Let this be something. So we are getting minus 200 minus 350 by 2 minus of minus 2. Minus 200 minus 350 by 2 minus of minus 200 plus 350 by 2 into cos of minus 60. And this will be minus 312.5 ampere. Similarly, tau xy for 1 can be written as minus of sigma x prime minus y prime by 2, and this is sine 2 theta, then tau x prime y prime cos 2 theta. So it will be minus of minus 200 minus of minus 350 by 2 into sine of minus 60 plus 0 into cos of minus 60. So it is coming out to be 64.95 MPa. MPa. Now we got this for one part. Similarly, we have to do for the case 2 also. Let me add one more slide and do it for you. So for case 2, similarly, sigma x for second one can be written as sigma x prime plus sigma y prime by 2 plus sigma x prime minus sigma y prime by 2 cos 2 theta plus tau x prime y prime sin 2 theta. So sigma x prime, sigma y prime, all are 0. Only thing is tau x prime is 58 MPa. So this will be 0 plus this will be 0 plus 58 into sine of 2 into 25 degree. So 58 sine 2. So this is coming out to be 44.4 MPa. Similarly, sigma y will be equal to sigma x prime plus sigma y prime by 2 minus sigma x prime minus sigma y prime by 2 cos 2 theta and minus tau x prime y prime sin 2 theta. So overall, what we will get? Minus of 44.4. Similarly, tau xy will be equal to minus of tau x prime y prime cos 2 theta, or let us write completely. So here it will be 0. So here it will be 0 minus 0 minus of 58 into sine 2 into 25 degree. So from here we are getting minus of 44.43 MPa. Similarly, tau xy can be written as minus of sigma x prime minus sigma y prime by 2 minus of sigma x prime minus sigma y prime by 2 sine 2 theta and plus tau x prime y prime cos 2 theta. So from here we'll get 0 plus 58 into cos 2 into 25, or 58 cos 52. So we are getting 37. So we are getting 37.34 MPa. So from everything we calculated the sigma x, sigma y and tau xy for the first part, first case and the second case respectively. Now just we have to superimpose to get the resultant sigma x, sigma y and tau x. So here I am writing sigma x will be sigma x from 1 plus sigma x from 2. So what we will get? Sigma x from 1 is nothing but 2 minus 237.5, and sigma x from 2 is nothing but 44.4. So minus 233 MPa. Minus 237.5 plus 44.4. So 193.09 MPa. So this will be minus 193 MPa. Similarly, sigma y will be equal to sigma y from 1 plus sigma y from 2. Y1 and sigma y from 2. So from here you can write minus things of 312.5 and minus 44.4. So minus 356.8 MPa. And tau xy will be nothing but from 1 and 2 if you will club, you will get 64.91951 plus 37.3. So it is 103 point. So sigma y we got sigma y from 1 and 2 we are getting minus 356.8, which is roughly equal to minus 357 MPa. So option D. This is the correct option. And if someone asks tau xy, we are getting tau xy x prime y prime from 1. Sorry. Tau xy overall will be tau xy and tau xy from 2. So we are getting 102.2. So this you will get 64.95 plus 37.34. So 102.102. 102.31. So with this, the today's session is over. So I hope you got this question. Now the stage is all yours. Please let me know if you have any doubt in any of the question, any feedback, anything you want to ask. Please let me know now. I am giving you another 5 minutes or 6 minutes. Please let me know. Otherwise, we will end the session here. So I hope there is no more doubt from your side. Then I hope let's wind up today's session with this. Thank you everyone for joining the session. Bye. Have a nice day.